For nearly 5 decades, two intrepid explorers have ventured into the darkest corners of our solar system and beyond, testing the limits of human ingenuity. The Voyager missions, launched by NASA in 1977, have not only transformed our understanding of the outer planets, but have also pierced the veil of interstellar space. These probes, Voyager 1 and Voyager 2, have traveled more than 13 billion miles, sending back groundbreaking data that has captivated scientists and the public. Recently, a transmission from interstellar space sent shockwaves through the scientific community. The explorers had encountered an unknown force in the vastness of space, the nature of which remains a mystery. What did the Voyager probe discover, and what stopped it from transmitting its findings immediately? Let's take a closer look at these fascinating facts. The Voyager missions began more than 4 decades ago and remain one of the most important and enduring achievements in the history of space exploration. Launched by NASA in 1977, the twin probes Voyager 1 and Voyager 2 were originally intended to explore planets beyond our solar system. However, their journeys have gone far beyond these initial goals, continuing to send invaluable data back to Earth from distant interstellar space. The history of the Voyager missions spans more than 35 years and 21 billion miles. It began in July 1972, when NASA began a project that would eventually lead to the launch of 2 spacecraft in 1977. These spacecraft were intended to explore the outer planets Jupiter, Saturn, Uranus, and Neptune. For nearly 5 decades, the spectacular Voyager space probes have explored our solar system and beyond, transmitting invaluable data back to Earth. However, the probe's latest transmission is the most shocking in 2 decades. NASA has officially revealed that the Voyager probes encountered an unknown force in the vastness of space, and the nature of this entity remains a mystery. What did the probes discover, and what prevented the probe from immediately transmitting this discovery? Let's dive into these fascinating events. The Voyager space probes have transformed into incredible time capsules that represent their era. These remarkable man-made space probes have boldly ventured beyond our solar system, charting new territories and bringing groundbreaking discoveries to scientists on Earth. Most people don't realize that these spacecraft have 3 million times less memory than the average smartphone and transmit data at speeds about 38,000 times slower than a 5G internet connection. Despite these limitations, these spacecraft, designed in the 1970s, have been some of the most successful probes ever launched. In a surprising twist, the probes recently made a discovery that has divided the scientific community. Many scientists hope the data was the result of an accident rather than a real one. The strangest thing about this accident is that it seems like the probes had to defeat an alien force to get this message to Earth. Before we dive into NASA's latest findings on the incident, let's take a closer look at these spectacular probes that have been tirelessly observing the cosmos on behalf of our planet. These 2 spectacular spacecraft were launched thanks to a rare celestial alignment that occurs every 176 years. In this particular case, the 4 largest planets in our solar system acted as guide stars. These planets, Jupiter, Saturn, Uranus, and Neptune, created a cosmic gravitational slingshot effect that accelerated the spacecraft as it passed each giant planet. It was as if the spacecraft was being pulled by an invisible celestial tether, propelling it forward with explosive momentum. However, this alignment has a major limitation. It only happens once every 2 centuries. This rare alignment presents a golden opportunity for interplanetary exploration. To take full advantage of this celestial event, a spacecraft had to be launched in the mid-1970s to reach these distant planets while the planetary alignment was still in effect. NASA took advantage of this unique opportunity and created 2 identical spacecraft to embark on this epic journey. In a thrilling display of space exploration, Voyager 2 began its remarkable journey from Cape Canaveral, Florida, on August 20, 1977, powered by a Titan IIIe Centaur rocket. On September 5, 1977, Voyager 1 followed suit and began its twin adventures across space. Its primary mission was to explore the gas giants of our solar system, Jupiter and Saturn, as well as the moons that surround them. However, these intrepid explorers went far beyond their original goal, embarking on a journey that took them to the farthest reaches of our celestial sphere. Voyager 1 and Voyager 2 have achieved many milestones during their epic journeys. They have survived longer than any other spacecraft in history and have ventured farther from Earth than any other man-made object. In fact, they have crossed the threshold of interstellar space, making them the first man-made objects to do so. Their journey into interstellar space, beyond the influence of the Sun and into the unexplored regions of the galaxy, has provided invaluable data that has left scientists amazed. As the pioneering interstellar probes approach Earth's distance of more than 20 billion kilometers, they continue to surprise physicists with their discoveries. One such astonishing discovery is a recent warning from the space probes, confirmed by NASA scientists. We will return to this in detail shortly. Voyager probes are distinguished by their use of self-powered radioisotope thermoelectric generators, RTGs. These types of nuclear batteries, also known as radioisotope power systems, use the Seebeck effect to convert heat from decaying plutonium into electricity. These RTGs operate efficiently without any moving parts, minimizing the risk of wear and tear and making them especially suitable for harsh and remote environments. A notable advantage is that these generators do not rely on solar energy, making them very advantageous for deep space missions. However, there is a catch. Over time, the plutonium decaying in the RTG gradually reduces its output power. The overall mission was not affected, though, thanks to proactive measures taken by NASA engineers. They strategically disabled heaters and non-essential systems that did not affect the spacecraft's ability to fly to compensate for the reduced power. But the engineering efforts didn't stop there. The Voyager spacecraft were designed to use an 8-track tape system to store and play back data. Here's how it works. First, the science instruments on the Voyager probes collect a variety of data, such as images, audio recordings, and measurements, and convert them into digital format. The digital data is then serialized and stored on 8-track tape, which has 8 parallel tracks for efficient storage. When it is time to transmit the data back to Earth, the onboard computer reads the data sequentially from the relevant tracks. The readout is transmitted via the spacecraft's communications system, which primarily uses high-gain antennas to send the information back to Earth. On Earth, receiving stations collect and decode the transmitted data, preparing it for scientific analysis. The materials used in these straps are specially designed to withstand the rigors of space. Magnetic tapes typically consist of a metal backing made from materials such as stainless steel, which is resistant to radiation, extreme temperatures, and the vacuum of space. Each track of the tape is coated with a magnetic material to store digital data, designed to resist degradation over time. The bands are also encased in protective casings to protect them from potential sources of damage, such as micrometeorite impacts. The longevity of these bands is remarkable. Despite their outdated design, they continue to operate and transmit data back to Earth on a daily basis. What are the notable achievements of the Voyager spacecraft? The achievements of the twin Voyager probes are not surprising. Their first observations of the moons of Jupiter and Saturn, made more than 40 years ago, amazed researchers and shattered previous assumptions about these distant worlds. These moons, once thought to be as inert and cratered as our own, turned out to be rife with geological activity. Voyager 2, in particular, has achieved several important milestones during its journey. As these spacecraft continue their remarkable journeys, NASA has taken a series of steps to extend their operational lives. Over the past 3 years, non-essential components and heaters have been turned off to conserve energy, allowing them to operate well into the next decade, with the mission estimated to end in 2030. For the scientists and engineers who have been involved in this extraordinary journey since its inception, the culmination of the Voyager missions is a bittersweet moment. Their dedication and hard work has resulted in the project performing better than they originally expected. The data returned by the probes has provided invaluable information, spurred countless scientific discoveries, and inspired generations of researchers and space enthusiasts. Voyager 1 and Voyager 2 were no ordinary spacecraft. They were meticulously designed to be stable platforms, rotating 15 times slower than the hour hand of a clock. This design minimized any image blur as the spacecraft captured images and data as they traveled through space. Their impressive imaging capabilities began to amaze scientists and the public even before they encountered the outer planets. The spacecraft began transmitting images of Jupiter when it was still months away. These first images, showing the gas giant, its swirling clouds, and its iconic Great Red Spot, delighted audiences at NASA's Jet Propulsion Laboratory. But it was the discovery of active volcanoes on Jupiter's moon Io that really paved the way for groundbreaking observations by explorers and astronauts. Io, slightly larger than Earth and the Moon, was found to be the most volcanically active object in the solar system. Instruments on the spacecraft and its astronauts detected spikes in Io's signals, which were confirmed by the dramatic images they captured. These images showed towering volcanic plumes and a surface marked by eruptions of volcanic material. Pele, one of Io's most important volcanoes, erupted at a height 30 times higher than Mount Everest, covering an area roughly the size of France.